Hello everybody, a very warm welcome to today's Rapid Fire Monday. This is your host, your dose, your catalyst and the quiz master mantle is what I'm holding today yet again, and I've come up with a very interesting topic. Before I proceed any further, quickly let me know if I'm audible and visible. I'm very sorry guys for the delay. We were facing technical glitch, very sorry. And now we are all set to get the dynamics sorted because the topic is also thermodynamics. So quickly let me know if I'm audible, visible, all is well. Sab changa, jaldi bataiye. Hi Pratham, hi Janvi, hi Prateek. All good? Karthik Gamer, hi. Am I audible? Am I visible? Is the audio in sync with the video? Quickly let me know. You're good to go is very important for me to begin this session for today. All good, Prateek. Thank you so much. So, yes, the topic for today is one of the very interesting topics, one of the very loved topic in the scientific community. I'm talking about thermodynamics, something that makes everybody crazy, something which is involved in everything, something whose scope is booming and amazing, I must say. Thermodynamics. Let us now have the three participants on the screen. Let me make you meet them. This is a very important session. Let me tell you, all that we have here is have fun. Fun with learning. We try to give you questions like which are truly the rapid fire questions. So we fire at you some questions, we bombard at you some questions, and you bombard me back with the answers. This is what rapid fire is all about, and to play this rapid fire with me, we have Chirant, Vaibhav and Niharika. Before we begin the whole journey of rapid fire, Chirant, Vaibhav, Niharika, in the same order, I want to know, number one, where are you from? Number two, which standard you are in? And number three, what are your hobbies? We'll start with Chirant.
I'm from Bangalore, Vidyaniketan, Aakash Integrated. My hobbies are I like drawing, I listen to music a lot.
What kind of music do you hear, Chirant?
Almost like English pop style.
Superb. We'll make you sing also if you win. Okay, Vaibhav, how about you?
I'm also from Bangalore, and my main hobby actually is playing the keyboard. I've been picking up on some guitar too lately, and I also draw sometimes.
Superb. Too lately, I do not know then what are you trying to call us, huh? We can't pick up a hobby right now, you mean to say, Vaibhav? Cool. Niharika, how about you?
Good evening, ma'am. I'm Niharika. I'm studying in class 11 from Aakash Rajajinagar. And my hobbies include drawing and reading novels.
Wow, which was the last novel you read, Niharika?
Ma'am, it was What Katie Did by Susan College.
Okay, cool. Super, we have very talented students it seems, and it's gonna be fun seeing them because it's going to be a healthy competition, like where you dissipate your pressure, where you have a learning experience, and everybody is a winner. The participant is certainly a winner because you're having a good time of learning. Whatever goes wrong, that's where you have to learn the most, and whatever goes right, there's a time to celebrate. Whosoever wins will get goodies from us, some vouchers from us. So yeah, that's the perk. But yes, like I said, the participation is the biggest thing. I'll quickly introduce how the rules look like. Let me have the rules on the screen. So guys, you have to be very quick. The one who will be quickest will get a +4. The second quickest will get a +3, and the third quickest will not be a quickest, but rather, the third person giving the right answer will get a +2. So +4, +3, +2 in order of the sequence in which you're giving the answer, you're typing the answer in the chat, right? So you have to be managing your typing skills also, that means. It's not just the game of knowing the answer in your head, but also typing it right there, right? So typing skills matter, your quick answer matters, but if there is a wrong answer, we'll give you -1. And you can also skip the question if you're not very sure. At least it's better to score 0 than a -1, right? So 1 mark will be deducted if it is incorrect, +4 if it is quickest, and the second one +3, third one +2. Any questions, guys? All set? Give me a thumbs up if all
Should we
set.
just type the question like option A or like the entire answer?
A, just A. It's rapid fire, Chirant. Be as crisp as possible. Alpha, ab main caps lock ya bina caps lock. Chill hai. Answer should come, right? Very quick. So it's a rapid fire, and rapid fire in the true sense. I would like you guys to take a deep breath in. Exhale out. Show me a thumbs up if you're ready. And we'll have the first question on your screens now. The temperature of the system decreases in an number 1, option A, adiabatic compression, option B, isothermal compression, option C, isothermal expansion, or option D, adiabatic expansion. Temperature of the system decreases. Let's see. Okay, Swastika, now you know the reason for the delay, huh? I'm glad you like the new screen of the RFM quiz. It's a compliment for the team also sitting here. Laika Walikar, Shukriya. Shukriya. Vaibhav is all ready with the answer. Let's see. How about the other two? The temperature of the system decreases in. All right. I can see in the chat, Prashant, Swastika, Astha, Mohit Yadav, Anand Raj, Prateek Singh, Sanjana, Janvi, all of them are bombarding me with the answers. Okay, do we have the answers of Chirant and Niharika yet?
Yes, ma'am, in the chat box.
How can we participate? Ikra is asking. Ikra, all that you have to do is fill up the form, which we roll out on the Fridays, right? Okay, so B and C have isothermal processes, तो उसमें तो temperature change होगा ही नहीं. Swastika Sanghi is helping you guys out here. Okay, so Chirant, I think Swastika has already given the answer that you said. Like Astha has also said exactly, जहाँ isothermal आया वहाँ तो decrease होना बनता ही नहीं है, boss. With the boss, so Chirant, of course, isothermal आते ही temperature constant है ना boss, है ना? तो C तो हमेशा यहाँ पे rule out करना ही मांगता था. C couldn't be your answer. In fact, B couldn't be your answer. So yes, indeed, what Vaibhav and Niharika had told me are absolutely right. Adiabatic expansion में temperature of the system will decrease. कैसे हो रहा है वो expansion? If we think logically also, not mathematically, we know that logically if there is an expansion taking place, so adiabatic, that means Q is not changing. How, what factor of the delta U are we going to utilize? किसके कॉस्ट पे होगा? टेम्परेचर जो है वो उस तरीके से निचोड़ रहा है Q कि टेम्परेचर कम होगा, एक्सपेंशन इसलिए होगा. इनफैक्ट लेट मी एक्सप्लेन दिस टू यू मैथमेटिकली एज वेल. लेट्स हैव द आंसर ऑन द स्क्रीन वेरी क्विकली. So you can see now mathematically how we can understand is W is equal to delta U, right? So delta U आपको पता है मैं इस तरीके से लिख सकती हूँ NCV डेल्टा T, और वर्क डन को मैं कैसे लिख सकती हूँ? केमिस्ट्री में तो -P डेल्टा V लिखते हैं, राइट? सो -P डेल्टा V, नाउ यू अंडरस्टैंड दैट हम क्या कर रहे हैं? एक्सपेंशन बोले तो V2 minus V1 is positive. So if V2 minus V1 is positive, that means delta T will be minus. Nothing else can be minus, right? So temperature of course will decrease. This is what mathematically also and logically also the same answer is coming up. In adiabatic expansion, the temperature decreases. Superb. So let's know the score very quickly, how the start has been. Everybody in fact in the chat has bombarded me with the right answer. Brilliant guys, brilliant. Very good. Let's see the answer, the scoreboard very quickly. Okay, Chirant. So buck up with the next one, okay? Anything can happen in rapid fire, so take a chill pill, nothing to worry about. I'm sure the scoreboards are going to look very different in the very end. So tension not. Well, Vaibhav was very quick here. 4 and Niharika 3. Wonderful start. Let's see the second question now on your screens. A thermodynamical system is changed from state P1V1 to P2V2 by two different processes. The quantity which will remain the same will be option A Q, option B W, option C Q plus W, or is it option D Q minus W? Thank you, KBGB. Thank you so much. Lots of love coming my way, this seems, huh? Thermodynamics is the topic, guys. Come on, start participating. Keep your dynamics on. Dynamics shouldn't go low. Absolutely full throttle it should be. So what are we doing? A thermodynamical system is changed from P1V1 to P2V2 by two different processes. So P1V1, say if we are going to P2V2, of course the path functions will not change, right? What will change is just the state function. And you know what are path functions, which depends on the path, है ना? तो path पे दो चीजें हैं जो हमारी thermodynamics की depend करती है. So path functions are Q and W. So A and B couldn't be your answers. 50-50 has already been done for you, huh? What are you left with? Option C or D. So which should be your right answer? Delta U is your thermodynamic process that we are talking about, the internal energy that we are talking about, delta U. And delta U is what? Is it Q minus W or Q plus W? Of course, Q plus W. So answer, please see, to this question is nothing but what Chirant, Vaibhav and Niharika has given. C is indeed the right answer. Bingo, absolutely right. हाँ, so हम कहाँ से हो गया boss? Ikra, Fayaz, D nahi, C. Please C. Answer is option C. So let me show you the answer once again, guys, so that it never goes wrong for anybody who has given it wrong. You know that what will not change is, of course, your delta U. So change in internal energy does not depend on the path. The only two path functions that you need to know is, of course, work and Q, W and Q. That's it. But Q plus W becomes delta U, which is nothing but your state function, right? Which will not change or will remain constant. Superb. So this was a question from the kind of functions. Now let's move on to the third one. I hope you guys are ready. Ready? Are you? All right, third question. For the process H2O liquid to H2O gas, the pressure 1 bar before, 1 bar afterwards, 373 before and 373 afterwards. The correct set of thermodynamic parameters is. Let's see how my lions are performing in the chat out here. Come on, guys, do write your question number and also give me the answer. Question number is needed. Question number, so that there is no lag between you or me. Let's establish the resonance. Let's establish the dynamics today because it's thermodynamics. इंटरव्यू में हैं आप, हाथ ठंडे हो रहे हैं, क्या है ये? थर्मोडायनामिक्स. आप चाय पी रहे हैं, ठंडी हो रही है, क्या है ये? थर्मोडायनामिक्स. आप कोई डाइट कोक पी रहे हैं या कोक पी रहे हैं और वो गर्म हो रही है, क्या है ये? थर्मोडायनामिक्स. So it's all about thermodynamics. So you guys must always imagine thermodynamics in order to master it, right? Okay. Are we ready with the answers? The set of thermodynamic parameters. We are going from water and water, but liquid and gas. And 317.3 Kelvin, who doesn't know, is the boiling point of the water. So if it is the boiling point of water, of course, what shall there be? Is it a condition of equilibrium or is it not? If it is a condition of equilibrium, delta G will be what? And if something is going from liquid to gas, what will happen to the entropy? All that you had to decode were these questions, and if you did, the answer couldn't go wrong. So do we have the answers? All three of you unanimously has given A as the answer. So of course, like I said, it's an equilibrium that we have. Water liquid is in equilibrium with water gas because at the same temperature, two different phases are existing. The phase water in liquid and the phase water in the gaseous form, and anything which is liquid at the room temperature but on heating becomes gaseous, we call the right term as vapor. So water vapors hai hamare paas और water liquid है हमारे पास at the same time, so delta G has to be 0 of course because it's the state of equilibrium, and if there is anything going from liquid to gas, disorderliness, the randomness is certainly going to increase, right? So everybody in the chat, Swastika gave the right answer, Suraj Edits gave the right answer, Vaibhav gave right, Ram Parvesh gave right, Abhishek also gave right, like Chirant, Vaibhav and Niharika. Many students in the audience has also given the right answer. Superb. A is indeed the right answer. Okay. Let's have the scoreboards. Let's see how you guys are doing. Okay. So we have Vaibhav acing it with 12. Niharika on the second position on the scoreboard with the 8. And Chirant on the 4th. But let me tell you, anything can happen in a rapid fire Monday. So maintain your momentum, maintain your mindfulness, make sure you are in the moment and bombard me with the answer. With this, question number 4 on your screens right now. During the isothermal expansion of an ideal gas, option A, delta U is constant. Option B, T is equal to 0. Option C, delta H is equal to 0. Option D, all of these. Fourth one, Yashaholic, क्या नाम है? Ikra Fayaz, yes. Let me tell you, you're asking me, are these for NEET? They are for both JEE and NEET because we are keeping the rapid fire questions. So आप इसको mains level और NEET level का बिल्कुल समझ सकते हैं. And in fact, this particular question which is in front of you is one of the favorite questions of examiner. मतलब ये अलग-अलग form में, I'm sure in n number of test series, mock tests, previous year you would have seen questions like these. Okay, so during the isothermal expansion of an ideal gas, हाँ, जरा unmute कर लिया जाए चिरांत, वैभव, निहारिका. मुझे बताओ, how come T equal to 0?
Ma'am, that is not actually the right answer.
What should be the right answer, Vaibhav?
A.
A. Delta U is equal to constant. Is Vaibhav?
Ma'am, the change in temperature is zero because it's
Yeah,
isothermal
so
and there's no.
change in temperature
But
should
is
be
it
zero, not the
change in
temperature itself.
temperature written?
No.
Delta
See, don't
U
do
is
typing
Delta
a
U.
constant which is zero.
So constant can be 5. Constant can be 10. Is delta U equal to 10? How do we know? It should be 0, right? Delta U should be 0. Delta H should be 0. Delta T should be 0. And you have fallen in the trap. Yippee, I love it. So, please, the moral of the story is read the question carefully. This is a trap. See, I know you guys, if you think over it for 1 minute once again, you would know why what you have typed is going to be wrong. Like Vaibhav already knew that T is equal to 0 is wrong. It should be a delta before the T to say B was right. Or delta U, that constant like Vaibhav said should be 0, then option A makes sense. So the only option which is making sense here is C. And I've seen option D also being bombarded because you see delta U equal to 0, delta T equal to 0, delta H equal to 0 as a common, सबसे ज़्यादा common question है ये. It comes in different forms, but यही है bait. Something which is following the pattern, there would be some kind of a psychological drama created by the examiner. So read carefully. Right, read carefully. Bhavya is saying change in internal energy is 0. Yes, so the delta H should be 0, not delta U. It is not that if we are saying delta U is equal to constant should be right. Make sure that constant has to be 0, then it's right. So C becomes the right answer. A -1 for all 3 of you. So that was like a no lead for anybody anyhow. So I'm sure with this, reading every small single nitty-gritty, maintaining the momentum is important. Keep that as a lesson from this question, and with this, let's move on to the question number 5. Question number 5 on your screens. The species which by definition has 0 standard molar enthalpy of formation at 298 Kelvin is option A Br2 gaseous, option B Cl2 gaseous, option C H2O gaseous, option D methane CH4 gaseous. Yes, Ikra fairs, they're held every Monday, so for different subjects, but every Monday, yes. So delta U, for the previous one, it's AB bro. It's AB bro. So delta H should have been 0 for the last question, okay? Chalo, come in the present moment. Don't forget to type the question number also in the chat, guys, everybody. And this is not for you. You do not have to write the question number, okay? You just have to write the quickest answer. Okay, so everybody is unanimously giving B, chlorine gas. How about bromine? In which state should it be then? Chirant, Niharika?
You're asking us. Bromine is liquid at room temperature.
And how about water? What state water should
Well,
be in?
Water is also a
Liquid.
liquid and it's a compound, so like that's 2 notes.
Okay. So with that, can you help me with the definition? What is a standard molar enthalpy of formation?
It's the enthalpy associated with the formation of 1 mole of the given substance, whichever substance you're talking about.
And it
So
has to
by-
come from?
Reactants in their element states.
And what kind of reactant should there be?
Gaseous reactant.
Sorry? So they have to be in their standard elemental state, right? So where has Niharika gone listening this? Okay, she's back. So yes, what Vaibhav has said is brilliant, absolutely right. We need to not have, we can never have, of course, standard enthalpy of formation equal to 0 for water because it's a compound. We rather make water using H2 gaseous plus O2 gaseous. For water, we could have enthalpy of formation, but that would never be zero, right? So, of course, for zero, they have to be in their elemental state number 1, standard conditions number 2, and that elemental state which is most stable, right? So, of course, Cl2 gaseous was indeed right. B, bingo. B becomes the right answer. Bromine and water be at liquid. Bhavya, no. Water, since it's a compound, we can't have the standard enthalpy of formation 0 for water or for methane for that matter, right? So, of course, chlorine had to be the right. It's AB, bro. H2O should be in liquid. Not at all. It shouldn't be in liquid. Even if it is liquid, doesn't make it to have 0 standard enthalpy of formation. Make sure you're reading it carefully. The definitions are important. This was a classic simple question based on simple definition of the standard molar enthalpy of formation. Let me show it to you once again. Standard enthalpy of formation of elements in pure state at 298 Kelvin and 1 bar is 0. So, of course, pure state, and we are talking about elements. Chlorine is gaseous at room temperature, whereas when we are talking about bromine, it should have been liquid, right? So, B was indeed bang on right. Superb. So, B should have been the right answer. Like most of you, like Tehlil, Abhishek, Mahi, Kuldeep, Ashish is saying, cool, cool, cool. Let's see the scoreboards. Vaibhav is acing it still. Let's see how the scores would look like in the end. The second position is backed by Niharika, and Chirant is following up very beautifully with the 6. Okay, let's see how the scoreboard changes with the next one. Next question on your screens. Generally, when a liquid solidifies, then what happens to the delta H? It becomes negative or positive. What happens to the delta S? It becomes negative or positive. When liquid solidifies. Imagine a liquid and it is going to a solid. What is happening to the delta S, the simple part, and then delta H? Let's see. Come on, scientific life is giving me an answer, which is A. Rohit is saying B. Lost is saying B. Ikra is saying A. So there's a A and a B coming in. Muskan is saying B. KBGB is saying A. Kuldeep Datta is saying B. Ek Learning is saying A. Ravi is saying B. Ishan is saying A. Ashish is saying B. Bhavya, question number 6A. And Chirant, Vaibhav, Niharika has unanimously given A yet again. Let's see whether they have aced it or not. Liquid to solid. Of course, you're right that entropy has to be negative. No chance. The disorderliness is supposed to decrease, right? So that is all right. So C and D couldn't be your answers. 50-50 was right there. A and B now, that was the hack here. Liquid is solidifying in general thing is what we are asking. So think of it as ice itself. If it is, solidifying, of course, if we are giving it heat, imagine if we are providing heat, that means when the delta H is negative, then what is going to happen is, if delta H is positive, if we are providing heat, delta H will be positive because we are giving it heat. So what will happen? It will rather melt, right? So of course, what you're saying, the delta H, the enthalpy should rather be released. That's why something is undergoing solidification. Hence, A indeed becomes the absolutely right answer. Superb. Superb. So, let's see the answer once again on our screens so that you never forget it. Abhishek Kumar shouldn't be C. Please see how the answer has come. Anybody who is giving me wrong answer. Right? Let's see. How is delta H negative and delta S negative once again? It's coming. Okay, conversion of liquid to solid is an exothermic process, hence change in enthalpy of course has to be negative. And when we are talking about conversion of liquid into solid, of course the randomness, the movement is going to decrease as something is solidifying until it's an egg. If egg is undergoing boiling, what will happen to the entropy? Can Niharika tell me? What will happen to the delta S if we are boiling an egg? It was liquid inside, but after you've boiled it, it becomes solid.
Ma'am, the entropy is decreasing.
Okay, you give side. It will increase or decrease?
Decrease.
It will decrease. So yeah, please make sure when we're talking about egg, protein or milk for that matter, what should happen to the entropy, Chirant?
Entropy increases more.
Why? Why so?
On the proteins and they're broken and
They're broken, then what happens? You're right. You're absolutely right.
they become their monomeric units, ma'am.
So we shouldn't say it becomes a monomeric unit. We should say rather it undergoes denaturation. Randomness increases. It becomes too random then. For earlier, proteins were properly arranged. Let's say A, B, C, D. They were properly arranged. There was symmetry, there was unanimous behavior, but then on heating it entangles, the globular structure mixes with each other and disorderliness. Even though it has become solid, what happens? The disorderliness increases. So is with the boiling of milk. So with that, let me also give you some life lessons here. Let's say if you boil your milk, right? Once it has been done, no? Second time, let's say you're consuming milk at the night or you're making tea. If you're overheating the milk again and again and you're thinking that it's gonna give me proteins, forget about it. So heat it least, because every time you're boiling a particular milk or any protein for that matter, of course what will happen is its protein behavior will decrease. So don't think that whatever milk, the content which is written at the back of the milk or any protein product, let's say, on heating, yes, you're decreasing the protein content because denaturation has increased. With that, let's see the scoreboards. Okay, Vaibhav on 18, Niharika is on 13 and Chirant is on 8. So let's do some, randomness now here in the scoreboards. All the best, Chirant and Niharika. Give Vaibhav a tough competition. Let's see with next question whether you can or not. Question number 7. When 2 mole of an ideal gas, its CV is given to you as 3/2R, heated from 300 Kelvin to 600 Kelvin at constant pressure, the change in entropy of the gas, delta S is Kr ln2. Find the value of K. Come on, guys. Question number 7. Bombard me with your answers. Everybody is doing it, huh? I hope you have your pen and a paper. You will require it. When 2 mole of an ideal gas, CV is given to you as 3/2R, heated from 300 Kelvin to 600 Kelvin, at constant pressure, the change in entropy of the gas is. What formula are you applying, guys?
Delta S equal to NCP ln T2 by T1.
Superb. So it's Cp. That was what I wanted to hear. And how do we find Cp? Chirant? By going to Delhi, we find Cp? That was a Delhi joke. So yeah. Chirant, how do we find Cp? No, you have to unmute yourself and speak. Niharika?
Yes, ma'am. Cp is the molar head capacity at constant pressure.
How do we find it?
It's Cp minus Cv equals R, so Cp is R plus Cv.
Absolutely, so don't forget that. Once you've done that, I think 5 by 2R is what you get. So of course there is 2 in the denominator and the moles are also 2. So 2, 2, tata bye bye. 5 should have been the answer, of course. And hence what you guys have mentioned, Chirant, Vaibhav, Niharika, bang on, C is indeed right. Superb. So everybody in the chat, what happened? Nitin, कैसे आ रहा है भाई 2.5? ऐसा मत करो. So we will find Cp. Yes, it's AB, bro. Yes, bro, you will have to find Cp. Cp minus Cv is equal to R. Yes, that's what you have to apply. That's it. And what Ishan is saying, NCp ln T2 by T1, which Vaibhav also said, which is the formula that you have to apply. And of course, what you get is C, which is 5. Anybody who missed it, please see the answer once again so that you never miss it. It's a learning experience that we are all here for. Let's see the answer. So you can see K would come out to be equal to 5 if you're using the right formula, which is delta S is equal to NCp ln T2 by T1. Cv was given. Cp you could easily find by adding R to the Cv. That's it. Cool. Ln 600 by 300, that was all sorted thanks to the examiner. The kind of question was very simple. Alright, let's see the scoreboard once again. Okay, Vaibhav still maintaining the ace with 22. Niharika on the second lead with 16. Chirant with 10. Okay, let's see how the scoreboards are going to look like. It's going to be, I think, a good battle with the next 7. So next 8 questions rather, right? In case we have a tie, of course, we'll have a free hit. Not a free hit, we will have another question. So we will never end with a tie. So let's see how the questions will change now, the scoreboard going forward. Be very quick. I'm going to increase the momentum a bit. So be in dynamics with me, okay? Next question, guys, on your screens. For a process to be spontaneous, very simple, delta G system, look at the subscripts very carefully, should be less than 0. B, delta S system, delta S surrounding greater than 0, delta S system plus delta S surrounding less than 0, both A and B. What do you think? Read it carefully, let me tell you, okay? That's the hack to the question, read it carefully, don't tell it to anyone. हाँ जी, विकास कुमार आंसर बताओ यार. Ravi is saying D, Shoyab is saying D, Rohit is saying A, Pranay is saying D, Vaibhav is also saying D, Ravi Charant is saying both, Vikas, answer, Ravi Charant, both, D, that means. Muskan is saying D, anything, anyway, C. Has Chirant bombarded us with the answer yet? Jeet is saying B. Dipesh is saying D. Anything, anyway, ma'am, C. Okay. Delta G has to be less than 0, of course. Delta G तो less than 0 होगा ही. तो निहारिका B क्यों बोला यार? A से क्या गड़बड़ है?
Mom didn't scan through the options correctly.
Oh my god, I think you scanned through the questions correctly, more correctly than Chirant and Vaibhav have. Subscript, I told you, read it carefully. Delta G is a function of, my dear? Delta G is a function of? Vaibhav? What do you think? The answer that you've given is right? Delta G subscript में क्या है?
Wait.
हाँ, Chirant, you saying something? Hello, I'm talking to you guys. कौन से ये निर्वाणा मोड में चले गए? Please come back. Tell me.
Ma'am, I'm a little confused now because
Delta G is a function of. Tell me this thing, Vaibhav. Come on. Volume and pressure. Ever heard it? Volume and pressure. Delta G. कहाँ है? Nation wants to know where is T. Temperature. T and P, बाबा. ये V कहाँ से आ गया यार? टेम्परेचर एंड प्रेशर, ये वॉल्यूम क्या कर रहा है यहाँ पे? कभी सुना है ऐसे वॉल्यूम? हम वॉल्यूम और प्रेशर के टर्म्स में बोल रहे हैं डेल्टा जी ऑफ द सिस्टम इज लेस देन 0. सो ऑफ कोर्स व्हाट निहारिका हैज स्कैन्ड, I do not know correctly or incorrectly, but intuitively right, B is indeed the right answer. The second law says that the entropy of the universe is always increasing. That means delta S system plus delta S surrounding has to be greater than 0. डेल्टा जी सिस्टम बहुत मजा आता है इसको देखते ही मार्क करने में कि हाँ A और B सही है. D, everybody in the audience is also saying D. Tell fast प्रज्वल, जो काम की चीज होती है ना वो आराम से आए तभी जाएगी यहाँ पर. तो प्लीज रीड द क्वेश्चन केयरफुली, अच्छे से ध्यान से एक एक सब्सक्रिप्ट को पढ़िए. मॉरल ऑफ द स्टोरी है ना. तो डी अच्छा टेम्पटिंग लगता है क्योंकि डेल्टा जी लेस देन 0, बट टेम्परेचर एंड प्रेशर. लेट्स सी द आंसर वंस अगेन. Delta G system, G is a function of temperature and pressure, not the volume and pressure, my lord. Hence, please be careful about these small little nitty-gritties which may end you up in soup. आप करके आओगे, बोलोगे नहीं मैं तो सही करके आया था. And here is not a -1, but rather a -5. Think of the 4 marks that you could have got and a -1 that you didn't get. So a -5 hence. इसलिए ऐसे सवाल जो बहुत सिंपल हैं गलत नहीं करने हैं. राइट? एवरीबडी लर्न्ड लेसन, isn't it? So let's see the scoreboard once again. Niharika would be very happy here, coming on a 20. Like I said, anything happens in a rapid fire. So Chirant, a lesson for you also. You know that you can still pace up and you can give a tough competition because anything can happen, right? Vaibhav is now on a 21, so Niharika is right there to give a tough fight to Vaibhav, and Chirant is following up. So bounce back, hashtag bounce back. With that, next question. Which of the following is our intensive property or properties? Temperature, viscosity, density, all of these. If you know the definition of intensive, this is a super easy question. Come on. Hashtag speed with accuracy. Speed with accuracy. Okay, so it was all of these what Chirant, Vaibhav and Niharika, all 3 of them are telling me. Yeah, viscosity भी. हाँ? Viscosity intensive होता है क्या? डेंसिटी इंटेंसिव होता है क्या? टेम्परेचर तो होता है.
Yes, ma'am. Density is
Cool. Alright, so they are not now falling in a bait. Indeed, D is absolutely right. Of course, अगर मैं बात कर रही हूँ viscosity की, तो अगर viscosity है या density है या temperature है, for example, if I'm in this room and there is an adjacent room just next to this wall, तो ये जो पर्पल वॉल दिख रही है इसके जस्ट पीछे एक और अगर स्टूडियो है एंड वी रिमूव दिस पर्पल वॉल, विल द टेम्परेचर हियर गेट एडेड टू द नेक्स्ट रूम्स टेम्परेचर? यहाँ पे 25 है, यहाँ पे 25 है, तो 50 हो जाएगा क्या? नो, राइट? Similarly, density will also not get added. Neither will viscosity. So they are intensive property which do not depend on the mass of the substance, right? And hence all of these are the right answer. D was indeed right. So temperature Rakesh Kumar hai, but uske saath saath viscosity as well as density, all three of them were the intensive property. Extensive add ho jati hai wo properties, right? So of course pressure is also an intensive property. You can't add pressures also, right? अगर pressure ऐसे add करने लग जाते तो मेरे ऊपर वाला जो room है उसका pressure मेरे ऊपर होता तो 1 atm यहाँ पे और 2 atm 1 atm ऊपर 2 atm, तो we would have probably fallen down because of such a high pressure. So all of you were bang on, going good, but density, it's AB bro. डेंसिटी अगर पानी का एक जगह पे 1 लीटर के पानी का डेंसिटी 1 ग्राम पर ml है और दूसरे का भी 1 ग्राम पर ml है, तो दोनों को मिक्स करोगे तो 2 हो जाएगा क्या? नो, राइट, इट विल स्टिल बी 1. सो इट इज इंटेंसिव. ऑल थ्री वर इंटेंसिव. Hence D was absolutely right. Let's see the scoreboard. Superb! So the lady is leading right now with 24 and she has a smile on her face now. Chirant is on 12 and Vaibhav, maza aayega ab. We will see now what happens with the next question on your screen. During an expansion of ideal gas, the work done by the gas is 100 joule and the heat capacity of the process is found to be +2 joules per degree Celsius. What do you have to find out? Delta U of the gas. If the temperature of the gas is 25 degrees Celsius higher than its initial temperature. In short, delta T is given to you. Heat capacity C is given to you. Work done by the gas is given to you. Delta U is what you have to find out. Come on, get set, go. प्रगति झा, आंसर दो यार. मैं हमेशा चंगा और कुछ नहीं. टेंशन नॉट. ऑल दे टॉपर्स, जल्दी बताओ. प्रज्वल, अपना आंसर बताओ. Jaldi, jaldi, jaldi. You would have to probably use your pen and a notebook to give me the answer for this particular question. What you have to find out is the change in internal energy. Bangaru Akhil is saying B. Dinesh is saying B. Subhashish is giving me B. Kuldeep is giving me B. It's AB bro is also saying B. King Shuk is saying B. Come on. Guys, be very careful. Be very careful. Delta U, you have to find out. Final temperature of the gas is 25 degrees Celsius higher than the initial temperature. That means delta T is equal to 25. Of course, what you have to find out is delta U will be equal to Q plus W, right? W is sorted. Work done by the gas, that means minus 100. So minus 100 is sorted. And Q, where do we find Q? What is the Q? C-U-E for Q, the alphabet Q. It is, of course, from the heat capacity that we have to find out. Simply C delta T will give us. So 25 into 2 is plus 50 is what we will get. So of course, plus 50 minus 100 will give you what? What? B. Be a rebel. You guys are totally being a rebel. What B is which is -50. Absolutely right. What everybody is B for bombarding me. Superb. Superb. All right. So let's see. Again, delta U, like I said, all that we needed to find out was Q, which we had the Q for because Q was equal to C delta T. So that was easy, very simple. Let's see the scoreboards very quickly. All right, so Vaibhav coming back to a 27, Niharika secondly 26, and Chirant following up. Chirant, yes, I know you can bounce back. 2 quickest answer and you would see things changing completely different. So all the best. The next one coming your way. Next question. Question number 11. Which of the following statement is correct regarding number of translational degree of freedom of the following gases? O2, O3, helium. One is a diatomic gas, one is a triatomic gas, and one is a monoatomic gas. Degree of freedom of the following gases. Which degree of freedom? Translational degree of freedom. 3 different types of gases. Monoatomic helium, diatomic oxygen, triatomic ozone. Jaldi se answer dijiye everybody. Rapid fire in the true sense. Should the monoatomic's translational degree of freedom be more than the ozone? That is a triatomic. Oxygen more than helium. O3 more than oxygen. Or none of the above. Okay, so Niharika, why D?
Ma'am, I got confused.
Okay, why B? If we go by your logic, ki diatomic is more than monoatomic, then C should have been also right. Triatomic should have been more than diatomic.
Monoatomic has 3 translation degree and diatomic has 5 and polyatomic has 6 translation degree of freedom.
Wow, where did you learn it from? Translational, Baba. इस तरीके से चलने की क्षमता, ठीक है? Look at this, the movement is like this, which can happen in only 3 directions, x-axis, y-axis and z-axis, no matter. We're talking about a monoatomic, diatomic, triatomic. Translational degree of freedom of gases would be 3 only. X है, Y है, Z है, और कौन सा Cartesian plane लेकर आ रहे हो आप? 70, Gen Z is in 70, is it? No, right? 3, only 3. All 3 of them had 3, so Niharika, you're being lucky today, yaar. Very nice. D is indeed the right answer, but yes, D, which is none of these, because all 3 had 3, not 3, 5 or 7 or something, right? You're talking about the degree of freedom total. That's not what the case is. So let's see the answer once again. For the translational degree of freedom, guys, all that you have to look at is translational degree of freedom of all gases is 3, which is fixed whether the gas is mono, di or tri. O2, O3, helium will have same translational degree of freedom. Never forget it, it's 3. X-axis, Y-axis and Z-axis. Right? So D becomes the right answer. XX, YY, ZZ, another way of saying it, right. Superb! So first, Ravi Chandran, you gave the right answer. I believe you. Prachi was saying D, very good. Arpan was also saying B, so this could have been a little tricky, but translational. Keep that in mind, okay? Vibrational जो degree of freedom है, that would come into existence only if we are taking higher temperatures, 700 degrees Celsius, तभी आएगा उसके ऊपर. उससे पहले हम उसको ignore करके चलते हैं. So what matters is translational plus rotational, which is different for different gases. So keep that in mind. And let's see now how the scoreboard is looking like. Okay, so Niharika now giving a competition coming on 30, Vaibhav on 26 and Chirant on 14. Superb. Let's see Now the toughness is coming for the second lead, I think. Okay, let's see. Next question, guys. Be very mindful and give me the right answer. Calculate the work done when 5 mole of oxygen gas contracts isothermally from 85 liter to 15 liter against a constant pressure of 2 atm at 25 degrees Celsius. Option A 70 liter atm. चिल केस है, सारे ही लीटर एटीएम है यूनिट्स, 14, 140 और 7. कितनी मोल्स थे? 5 मोल ऑफ ऑक्सीजन गैस है. क्या हो रहा है? कॉन्ट्रैक्ट कर रही है आइसोथर्मली. कहां से? 85 लीटर टू 15 लीटर. कम ऑन. कुलदीप दत्ता इसे निहारिका बाजी मार लेगी. लेडीज ऑलवेज फर्स्ट. So a lot of lady love is coming towards Niharika. A lot of support is coming to you, Niharika. Superb. Let's see what is going to happen. So what do you have to apply here? What formula? If formula is clear, the calculations are super simple. Let's see what everybody in the audience is saying. Piyush is saying C. Bangaru Akhil is saying B. Piyush is saying A now, huh? Okay, other Piyush. There's Piyush 24 and Piyush Tale. Okay, work done of isothermally applied. Arpan, वाह क्या बात है. Formula बताओ यार, ये क्या होता है? Which formula you applied? The work done for the isothermal gas is applied. Very nice. Okay, A, C, all these kind of answers are coming up, but I can see Chirant, Vaibhav and Niharika, all three of you giving me option C as the answer. Why so? Kahe ko?
Ma'am, I just went with the P delta V because the minus 2.303 RT log V2 by V1 for isothermal reversible process.
Yes, and moles will not play a difference.
No.
Okay.
It's based on the pressure
so
and
yes,
the volume.
That was the hack. Moles could have played a difference, but yes, agar I think 5 से multiply करते तो कोई option नहीं था, so there was nothing to confuse us. P delta V was indeed right. 2 into 85 minus 15 is going to give you 70. 70 into 2 is 140. 140 liter ATM is indeed right. Please see the right answer to this question is indeed option C. And now let's see the scoreboards. Niharika still acing it with a 32. Vaibhav is on 30 and Chirant is on 17. Okay, so nothing to worry about. We are learning. It's a learning experience. Let's enhance it with the next question. The work done when 1 mole of an ideal gas in a 10 liter container at 1 atm is allowed to enter into an evacuated bulb of capacity 100 liter. Let me help you guys. Read carefully, okay? Don't tell it to anybody. What is our audience saying? Santosh, क्या लग रहा है? क्या आंसर है? The work done when 1 mole of an ideal gas in a 10 liter container at 1 atm is allowed to enter into an evacuated bulb of capacity 100 liter. 10 लीटर से 100 लीटर जा रहा है. 1 मोल आइडियल गैस. Shweta is saying C. Deepu Yadav is saying A. Akhil is saying C. Vaibhav has also given the answer. Chirant has also given the answer. Do we have answer from Niharika? Rapidly fire the answer. 1 mole gas hai. Shreya Chaube is saying C. Shweta is saying C. Dinesh is saying A. Harsh is saying A. Tia Tiwari is saying A. Shweta is saying C. Harsh is saying A. And Niharika is also saying D. जबकि मैं सभी के गलत आंसर बोली जा रही थी, but yes, यहाँ पे कोई टस से मस होता नहीं है गलत आंसर सुन के. That's fantabulous. Why 0 but?
Evacuated bulb implies that there's no external pressure.
Superb. There's no requirement for me to explain it. Vaibhav has explained it beautifully. Evacuated का मतलब हम जानते हैं pressure external 0 है, तो of course answer हो जाएगा 0. D. Evacuated हो, vacuum लिखा हो, पूरा गैस हमने निकाल दिया है, ऐसा कोई इंग्लिश लिखा हो. We know how to deal with these kind of questions, and these are exactly the question where we can do some balle balle, because of course the answer is 0, no calculations required. So D, which is 0, was indeed right. Let's see the answer once again. So of course vacuum की बात हो रही है, तो pressure आप क्या लेंगे? 0 लेंगे. pressure को 0 लिया तो वो क्या होगा? 0 होगा. और क्या होगा? तो A, B, C कहाँ से दे रहे थे यार आप लोग? हैं? देवांश कहाँ से B हुआ? यशा कहाँ से C हुआ? How come A, B, C could have been your answers? अखिल कौन सी कैलकुलेशंस कर रहे हो यार? ये रोहित A कह रहे हो. Please make sure you learn from it whatever you're doing wrong. And at the end of the quiz, do let me know your score as well. I would love to know. Okay? Their scores I will be telling, of course. Chiran's, Vaibhav's and Niharika's score I am going to tell. Your score you will tell me. Okay, with that, are you guys ready for the second last question? Chiran, was it that or no? Alright then, next question on your screen. There is an insect moving, let's say cockroach moving, on horizontal floor, E, on which it can only move forward, backward, or turn left or right. What is the degree of freedom of that cockroach? 2, 3, 4 or 6? That is interesting. That was an eeky question, but nonetheless very interesting. Okay, so let's see what audience is saying. We have our participants' answer already. Let's see whether they have A for aced it or not. Venkat is saying A, Rohit Kumar is also saying A, Royal Gamer is saying B, RJ is saying B. 3, okay, 3 आ रहा है बहुत सारे बच्चों का. Yash is also saying B. Cosmic Aditya is saying A. वाह, Cosmic Aditya, क्या बात है. Superb. Rohit Kumar is also saying A. Archana Shukla is saying A. Renu Vishwan is also saying A. So why A, guys? What happened? 4 नहीं होगा क्या? आगे भी है, पीछे भी है, left भी है, right भी है.
Forward and backward.
Only in XY plane.
One dimension.
Super.
So like
1 dimension, yes. This is 2 dimension, yes. So एक horizontal surface हुआ 2 dimensional surface. So there is one X and Y involved in a 2 dimensional surface. It can't fly luckily, but yeah, once a cockroach actually flied and sat on my cheek once. So yes, it can fly unluckily. I don't like cockroaches at all, but degree of freedom for that should be 2. And hence the answer which is right is indeed option A, 2. Super. You want to see the answer once again? See it. Anybody who is giving me B, please see it. So of course it can't fly, and since it cannot fly, it can't move in one of the direction. Assume it to be in Z direction, okay? Z ऊपर हो या नीचे doesn't matter, it will still be Z. So of course there are only 2 degrees of freedom. A beautiful question to understand degree of freedom. Let's see the answers, the scores right now. Your answers has awarded you how much score? Hoo hoo hoo. So we have a tie here. That means the last question is indeed our tiebreaker. Chirant has really bounced back with 25. Chirant, bang on. Make sure the next one you give a lead here, and then we'll see. Anything can happen if one answer goes wrong. If one answer goes quickest, certainly the scoreboard is going to look something very different. Excited? I can't see the excitement. Chirant keh rahe yaar, main kyun excited hu? Is it Chirant?
Oh, Mama, I'm excited.
Stay excited. Stay mindful. Stay in the best of your spirits. And let's see the last question of the rapid fire on your screens. Which of the following is incorrect for the reversible adiabatic expansion of an ideal gas? Vp to the power gamma is equal to constant. Tv gamma minus 1 is equal to constant. T gamma P 1 minus gamma is equal to constant, or none of these. Alright, so I can see the quickest answer has come by the person who is already smiling. So, right answer, I can't say. The last question should go wrong. Of course, all is well, that should end well, and it has ended very well because all three of you, Chirant, Vaibhav, Niharika, you have given me right answer. PV to the power gamma is equal to constant. What should be the right equation, by the way?
PV to the power gamma.
EV to the power gamma.
Ulta hona chahiye tha. PV gamma has to be constant. That's absolutely right. So A is indeed the incorrect answer. Let's see the scoreboards. All right. How does it feel? Vaibhav is a clear-cut winner. Niharika, what tough competition you gave, huh? Chirant is on 27, but you bounced back, I must say. So, how does it feel, Vaibhav?
It was intense in the middle for quite a while.
I thought in the end. Niharika, how about you? How are you feeling?
I'm feeling good, ma'am.
You gave very tough competition. I'm sure it's a game of hashtag speed with accuracy, isn't it? So a little quickness and you could see that the answer could have been yours. Mindfulness was important. Chirant, how about you? How does it feel?
Nothing, Ma'am, blank.
Blank? Why blank?
Like first question went wrong, Ma'am. Confidence.
So that's what we learned from today. Dissipate your pressure. This is what that happens, let me tell you, in examination hall also. For example, you do something wrong. Maybe you've written your roll number wrong, let's say, in your sheet. And that creates a havoc in your brain. So always train your brain for such psychological drama that can happen. So these kind of platforms are really good for that because you dissipate all your pressure. And once you are in the moment, in the present moment, the left or the right, up or below doesn't matter. You are in the moment. Degree of freedom, just one. Right? So I'm sure you had a good time. Everybody, audience poll is right. हाँ, ये वाले answer के लिए तो था. Last question was indeed very simple. So with this, superb, congratulations Vaibhav, well played, and Niharika, very well played, because I still could not guess at the end who is gonna win. You were always giving him a very tough competition throughout. And Chirant, well played, because you started with a minus, hence I can understand it can bring in some drama in the brain, but that's what we are here to learn. The winners are all three of you. So with this, guys, we've come to the end of the session today. Yet another episode of Rapid Fire Monday. I hope you had a great time. I hope you had a learning experience. This is me, Natika, signing off. Take a good care of yourself. Bye-bye.